Hi everyone, and welcome to the third of 4 videos going through some past exam questions on the topic of the halogens. So this first question we've got here, the student is trying to prepare barium bromide by reacting barium and bromine. They weren't sure whether this preparation would be more reactive or less reactive than calcium chloride from a previous question. So why were they unsure of the relative reactivity? So this is kind of linking together what we know about group 2 elements and what we know about group 7 elements. The reason why we're not sure of the reactivity is because, well, barium, if we look at the periodic table, barium is further down the group than calcium. So barium is going to be more reactive than calcium. Remember, the group 2 elements get more reactive down the group because it's easier for them to lose the 2 electrons. So barium is more reactive than calcium. But then if we compare bromine and chlorine, okay, chlorine is going to be more reactive than bromine because as you go down group 7, they get less reactive because it's more difficult for them to gain an electron. So here, if we think about our barium bromide, the barium is going to be more reactive than the calcium, but the bromine is less reactive than the chlorine. So how do we know which combination is going to be more reactive? It's difficult to tell. Okay, and so that's the general idea behind this question. That's actually all we need to write. But this kind of idea comes up in quite a few other areas. Just this concept of there are 2 things going on that are acting in opposite directions, and I don't know which one of them is more important. Okay, this comes up in quite a few other areas. This concept of why doesn't the student know which of these is going to be more reactive, or why doesn't the student know which of these values is going to be bigger? And it's usually because there's one factor making it go in one direction and another factor making it go in the other direction, and you don't know which is more important. Okay, this question here is saying, in drinking water, we've got this HClO, which kills bacteria. Write an equation to show how it can form. So this is the product when we add chlorine to water. Okay, so it's when you react chlorine with water. This is that disproportionation reaction where you end up with HCl and HClO. And then it just needs balancing. We've got 2 hydrogens, 2 chlorines, and 1 oxygen. Actually, that's it. It is balanced. Okay. So that's it. That's quite a nice, easy one. Some scientists believe that chlorine compounds should not be present in drinking water. Okay, suggest one reason why scientists are worried by the presence of these compounds. Now here we need to be careful because they're asking about chlorine compounds. Okay, one of the biggest problem with adding chlorine to water is that chlorine is toxic. But it's not asking about chlorine, it's asking about the chlorine compounds. Okay, and there is evidence suggests that chlorine compounds may cause cancer. Or the word that you can use, you can say they may be carcinogenic, which means they can cause cancer. And they do get quite picky about this. It's, you know, when chlorine reacts with some other thing to make a compound, there's evidence that those compounds may cause cancer. Chlorine does not cause cancer. Okay, and chlorine compounds are not toxic. The chlorine itself is toxic. So we've got to be careful with how we're writing this question. Okay, they will get picky about it. If we look at some other questions here, a lot of these questions are very similar to questions we've seen in some of the earlier videos, but I wanted to go through them just to show you that point and say, look, you need to make sure you can do this. You need to make sure you can do this because the same questions keep coming up. So what's going on here? During extraction of bromine, chlorine is bubbled through a solution of bromide ions. The student thought this principle would also work for extracting iodine. Okay, so they bubbled some chlorine through a solution of potassium iodide. And then they added an organic solvent and shook the mixture. What would they see in stage 1? So this is before they've added the organic solvent. So if we just bubbled chlorine through potassium iodide, then the chlorine would displace the iodine and we'd see a sort of a reddish brown colour. Okay, I'm looking at the mark scheme as I'm doing this, and they will give you sort of any shade here. The mark scheme says you can have yellow, orange, brown, red, reddish brown. So anything sort of in that ballpark between yellow and brown, they'll let you get away with. So then name the products and write an ionic equation. Okay, so what's going to happen is the chlorine's going to displace the chlorine's going to displace the iodine from the potassium iodide, and we're going to end up with potassium chloride and iodine. And then the ionic equation, so we're going to have chlorine is going to react with the iodide ions, and we're going to end up with chloride ions and the iodine being displaced. Why does the reaction in stage 1 occur? Well, because chlorine is more reactive than iodine. It's only a 1-mark question, so we're not going to have to get into explaining why chlorine is more reactive than iodine. What would the students see at stage 2? So stage 2, we've added the organic solvent, so this is going to be the cyclohexane. And remember, the point of adding that is to make the colour clearer, because this is a similar kind of colour to the orangey brown of the bromine water. So if we put it in the cyclohexane, we're going to see a purple colour. And then that's clearly different to the bromine. Right, the last question we're going to look at here is the same question that we saw in a previous video about the trend in the boiling points. So we can see that the boiling points are increasing as you go down the group. So we're going to get a mark for that. Okay, so the boiling points increase down the group. And if you watched the previous video, you would have already seen the answer to this. This is because the elements further down the group have more electrons, so their London forces are stronger, and require more energy to overcome. Remember, we talked about always adding that in to get yourself an extra mark. Okay, the more electrons you've got, the stronger your London forces are going to be. Okay, and therefore it's going to take more energy to break those forces, and therefore you're going to have a bigger boiling point.